All right, space cadets, gather round. Today we're diving into the captivating world of the cosmos with the James Webb Space Telescope, or JWST. Launched in December 2021, this $10 billion masterpiece is the largest and most powerful space telescope ever built. Imagine a telescope so advanced it can peer billions of years back in time, capturing light from the universe's earliest stars and galaxies. It's like having a time machine with cutting-edge mirrors and instruments. JWST isn't just about nostalgia, it's also busy unraveling the mysteries of our own cosmic neighborhood. From capturing stunning images of distant nebulae to analyzing exoplanet atmospheres, JWST has already made groundbreaking discoveries. So what makes JWST the Neil Diamond of space telescopes? Its massive size allows it to collect more light, seeing fainter and more distant objects than any telescope before it. JWST is equipped with 4 state-of-the-art scientific instruments, each designed to analyze different aspects of light. Think of it as a cosmic toolbox equipped to tackle any celestial mystery. Its infrared vision can penetrate clouds of gas and dust, allowing JWST to see through the cosmic haze. All these features combined make JWST an unparalleled tool for scientific discovery. Now brace yourselves because we're venturing into the realm of brown dwarfs, those enigmatic celestial objects that are too big to be planets but too small to be stars. These cosmic misfits have always fascinated astronomers, occupying a strange middle ground in the celestial hierarchy. With turbulent atmospheres and unpredictable behavior, brown dwarfs are like the awkward teenagers of the universe. JWST, with its powerful infrared vision, has provided an unprecedented glimpse into these mysterious objects. We're not just learning about brown dwarfs, but also about the formation and evolution of stars and planets. All right, space fans, let's talk brown dwarfs. Imagine a celestial body bigger than Jupiter, but not massive enough to ignite into a star. These cosmic oddballs are often called failed stars because they don't sustain nuclear fusion in their cores. But just because they're not full-fledged stars doesn't mean brown dwarfs are boring. The James Webb Space Telescope, with its keen infrared vision, is the perfect tool to spy on these celestial teenagers and unravel their secrets. So buckle up, space cadets, as we delve deeper into the world of brown dwarfs. Now let's get down to the nitty-gritty. Brown dwarfs are smaller than stars, but still pretty hefty, anywhere from 13 to 80 times more massive than Jupiter. They emit a faint glow, mostly in infrared light. Brown dwarfs are thought to have complex atmospheres, similar to gas giants, but with some key differences. We're talking clouds of exotic materials, powerful winds, and maybe even sandy storms. JWST's ability to analyze the light passing through these atmospheres gives us an unprecedented look at their chemical makeup and weather patterns. It's like having a cosmic weather report, but instead of rain or shine, we're talking about silicate clouds and high-speed winds. This is where JWST comes in, folks. Remember those 2 brown dwarfs I mentioned earlier, practically our next-door neighbors in cosmic terms? JWST has detected evidence of hot, sandy winds whipping around these celestial bodies. At these temperatures, elements like silicon and oxygen can combine to form tiny dust grains, essentially sand. By studying these winds, scientists can learn more about the atmospheric dynamics of brown dwarfs and how their atmospheres evolve over time. These observations can also provide insights into the atmospheric processes occurring on other worlds, both within and beyond our solar system. So yeah, sandy winds on a brown dwarf, it's more exciting than it sounds. Picture this, a binary system of brown dwarfs, just hanging out in space, minding their own business. They're the 3rd closest system to our very own sun. This dynamic duo, known as WISE J104915, 57, 531,906.1 is a mere 6.5 light-years away from us. But don't let their proximity fool you. These brown dwarfs are notoriously faint and difficult to observe. Luckily for us, JWST, with its incredible sensitivity and infrared vision, was up to the challenge. the telescope's observations have given us a front row seat to the fascinating and slightly sandy drama unfolding in their atmospheres. Let's talk about how JWST managed to capture these groundbreaking observations. Unlike traditional telescopes that primarily observe visible light, JWST is designed to see in infrared, a wavelength of light invisible to the human eye. Infrared can penetrate through clouds of gas and dust that would normally obscure our view. Brown dwarfs emit a significant amount of their light in the infrared part of the spectrum. Thanks to its advanced instruments and unprecedented sensitivity, JWST was able to detect the faint signatures of hot, sandy winds swirling around these brown dwarfs. So, how do we know there's actually sand involved? It's all about the spectral data. When light from the brown dwarfs passes through their atmospheres and reaches JWST, the telescope's instruments can break down that light into its individual wavelengths, creating a spectrum. Scientists found distinct signatures of silicate dust, tiny grains of sand, moving at incredibly high speeds, indicating powerful winds. This discovery isn't just about finding sand in unexpected places. It's about gaining a deeper understanding of the complex processes occurring in the atmospheres of brown dwarfs. The universe is full of surprises. Let's talk about these hot, sandy winds. We're talking about powerful, turbulent flows of gas and dust that can reach speeds of thousands of kilometers per hour. Brown dwarfs, despite being failed stars, still generate a significant amount of internal heat. This heat, combined with the rotation of the brown dwarf, creates convection currents that drive these powerful winds. By studying these winds, scientists can gain a better understanding of how energy is transported and distributed within brown dwarfs. It's like studying the weather patterns on Earth, but instead of predicting rain or shine, we're unraveling the secrets of these enigmatic celestial objects. You might be thinking, okay, so we found some sandy winds on a couple of brown dwarfs. Interesting, but what's the big deal? This discovery has far-reaching implications for our understanding of not just brown dwarfs, but also giant planets and even the formation of stars and planetary systems. By studying brown dwarfs, we can gain insights into the atmospheric processes occurring on giant planets, both within and beyond our solar system. Understanding the dynamics of brown dwarf atmospheres can also shed light on the processes that govern the formation and evolution of stars and planetary systems. As JWST continues to observe these and other brown dwarfs in more detail, we can expect even more groundbreaking discoveries. Brown dwarf atmospheres are wild. We're talking about environments so extreme, so different from anything we experience here on Earth, that they might as well be on another planet. These extreme environments offer a unique opportunity to study physics and chemistry under conditions that we could never replicate here on Earth. It's like having a cosmic laboratory where we can observe the behavior of matter at its most fundamental level. These hot, sandy winds are a window into the complex processes that govern brown dwarf atmospheres, and by extension, the atmospheres of giant planets and even the early stages of star formation. Section 2, Sand in the Circle of Life, Cosmic Recycling at its Finest. Now I know what you're thinking. Sand? In space? What's next? Cosmic beaches? Well, not quite. But the discovery of sand, or more accurately, silicate dust in brown dwarf atmospheres, does highlight a fascinating aspect of the cosmos, cosmic recycling. Think about it. The elements that make up you, me, and that latte you had this morning, they were all forged in the hearts of stars billions of years ago. When those stars exploded, they scattered those elements throughout the universe, seeding the material for new stars, planets, and yes, even brown dwarfs. Talk about a stellar inheritance. And just like on Earth, where sand is constantly being eroded, transported, and redeposited, the same thing happens in space, but on a much grander scale. These hot, sandy winds on brown dwarfs are a testament to this ongoing cycle of cosmic recycling, where elements are constantly being shuffled around, forming new structures and giving rise to new generations of celestial objects. So the next time you're at the beach, take a moment to appreciate the sand beneath your feet. It's not just a nuisance, it's a reminder of the interconnectedness of the cosmos and the incredible journey that matter takes over billions of years. All right, let's talk exoplanets, those tantalizing worlds orbiting distant stars. We've discovered thousands of them in recent years, ranging from scorching hot gas giants to potentially habitable Earth-like planets. Brown dwarfs can help us understand them better. They share striking similarities with giant planets. Both have thick atmospheres and complex weather patterns. Studying brown dwarfs gives us a sneak peek into the atmospheric processes of distant worlds. We can learn about the potential building blocks of life on other worlds. Brown dwarfs provide valuable insights into planets beyond our solar system. Let's give a round of applause to the James Webb Space Telescope, aka the coolest, most powerful telescope ever built. This technological marvel is like the Sherlock Holmes of space, equipped with the latest gadgets and a keen eye for detail. JWS has revolutionized our understanding of the cosmos, capturing stunning images and peering into star-forming regions. Analyzing light from distant objects, JWS reveals secrets hidden for billions of years. Observing in infrared, JWST sees through gas and dust, studying atmospheres in new ways. As JWST continues its mission, expect groundbreaking discoveries that challenge our understanding of the universe. Buckle up, space fans, because the future of astronomy is looking bright thanks to JWST. All right, folks, let's talk real estate, Cosmic Edition. When it comes to studying celestial objects, proximity is key. And these brown dwarfs, well, they've hit the jackpot in the location department. Remember, they're the third closest system to our sun. That's like finding a parking spot right in front of the bakery on a Sunday morning. Pure luck. But this stroke of cosmic serendipity isn't just about convenience, it's about opportunity. Being so close means these brown dwarfs appear brighter to us, allowing telescopes like JWST to gather more light and data. It's like having front row seats to a concert. You get a much better view of the action. This proximity also allows for more detailed observations of their atmospheres. Remember those hot, sandy winds we talked about? Well, being closer means we can study those winds with greater precision, unraveling their dynamics and composition in ways that wouldn't be possible with more distant brown dwarfs. It's like having a high-resolution camera. You can zoom in on the details without sacrificing clarity. So yeah, these brown dwarfs lucked out in the location department. But hey, it's our lucky break too. Their proximity provides us with an unprecedented opportunity to study these enigmatic objects in detail, and in doing so, gain a deeper understanding of the universe we call home. Brown dwarfs, they're not quite stars, not quite planets, but they hold valuable clues to both. Think of them as the missing link in the cosmic evolutionary chain. By studying brown dwarfs, we're gaining insights into star and planet formation and the diversity of worlds beyond our solar system. It's like finding a Rosetta Stone for the cosmos, helping us decipher the language of the universe. These hot, sandy winds, they're more than just a curious phenomenon. They're cosmic stepping stones, guiding us towards a deeper understanding of the universe. And with JWST leading the charge, we're in for an exciting ride of discovery. All right, space cadets, let's recap, shall we? We've journeyed into the heart of brown dwarfs, those cosmic in-betweeners, marveled at their turbulent atmospheres with clouds of exotic materials, and uncovered hot, sandy winds, showcasing the universe's diversity. These discoveries represent a major leap in understanding these enigmatic objects. Thanks to JWST, we're seeing brown dwarfs in a new light, unraveling their secrets. These are our cosmic neighbors, residing a stone's throw away in space. Their proximity provides a front-row seat to the dance of matter and energy. Reflecting on these discoveries, let's appreciate the awe-inspiring cosmos. With JWST as our guide, we're uncovering the universe's mysteries. The discovery of hot, sandy winds on brown dwarfs is just the tip of the cosmic iceberg. As JWST continues to scan the heavens, we can expect a deluge of new discoveries that will challenge our assumptions, spark our imaginations, and deepen our understanding of the universe and our place within it. Imagine this, JWST peering into the atmospheres of exoplanets, searching for signs of life beyond our solar system, or witnessing the birth of stars and planets in real time, capturing the awe-inspiring spectacle of cosmic creation. Or maybe even unveiling the secrets of dark matter and dark energy, the mysterious forces that shape the destiny of the universe. The possibilities are literally astronomical. But the future of space exploration isn't just about telescopes and technology. It's about people, about the insatiable curiosity that drives us to explore the unknown, to push the boundaries of knowledge, and to seek answers to the biggest questions we can ask. It's about the spirit of adventure, the thirst for discovery, and the unwavering belief that the universe holds endless wonders waiting to be revealed. So, keep looking up, space cadets. Keep asking questions. Keep dreaming big. The universe is calling, and with JWS as our guide, we're ready to answer. The adventure has just begun.